Hello, I'm Jason Fensky from Engineering Explained, and in this video we're going to be learning about flooded lead-acid batteries, the most common form of batteries you'll find in production cars. So looking at the construction, you've got 6 individual cells, and within each cell you have multiple plates, both positive plates and negative plates. So you can see here between those positive and negative plates you have a permeable separator, and then all of these plates are resting in an electrolyte solution, so it's 65% water, 35% sulfuric acid. Now the negative plates want to react with that electrolyte solution and lose electrons. So when you connect these two terminals to whatever you're powering, the positive lead plates want to take those electrons from that reaction from the negative lead plates and that electrolyte solution, react with it, take in those electrons, and then produce water. Now if we take a closer look at these individual cells, as mentioned, there are multiple plates in each. So here you can see you've got 3 different positive plates, and it's actually quite a few more than that. Those are connected to a cell connector, and then on the other side you're going to be connecting to the negative plates. So those positive plates all connect to one cell connector. So you've got your tombstone weld, which connects the cell connector with the negative plates to the cell connector with the positive plates through the cell wall, multiple plates on each, and then of course you have separators between each of these different plates. Now each one of these cells produces about 2 volts, and you have 6 of them in series, so you can do the math, 12-volt battery. Now in reality it's more like 2.2 volts, so times 6 you get about 13.2 volts for a 12-volt battery. Now some things you need to know about flooded lead-acid batteries: they can require maintenance where you may need to add water as they are not sealed. So because that solution in there is free-flowing, you can have hydrogen and oxygen escape, and so occasionally you may need to add water. Also, as a result of that electrolyte solution being free-flowing, you need to make sure that the battery is situated upright so that you don't have any spills. And finally, if you're using this type of battery in situations where you're going to have a lot of vibration, it could have some damage from that vibration. You could have the negative plates or the positive plates detach from the cell connector. You can also have some of the active material that's on these plates fall off, and they actually have space at the bottom of these batteries to allow for that debris to kind of collect. And also you could have, in super severe vibration scenarios, you could have that separator pierced and then short out the circuit by connecting the positive and the negative plates. Now these type of batteries are fine for most OEM applications. However, some manufacturers are looking towards absorbed glass matte batteries for their added benefits. So a huge thank you to Optima, and thank you all for watching. If you have any questions or comments, feel free to leave them below.